So let me give you a number of examples where we don't have to solve the equation and we don't have to know what the roots are. We can know the nature of the root just by looking at it. So let's do the first example. So the first question can be, find the nature of the roots of the quadratic equation x squared plus 5x minus 10 equals to 0. So we need to find the nature. We don't need to solve it. We don't need to know what the values of x are. We need to find the nature of the root. So this would be, so b squared minus 4ac. Let's see what the value is. So 5 squared minus 4, a is 1, coefficient of x squared, and c is minus 10. So this would be 25 plus 40. So minus 4 into minus 10 is 40. So this would be 65. So you can write, since b squared minus 4ac is greater than 0, roots are real and different. So that's it. In another question, they might say, given the roots of x squared minus 2x plus k equal to 0 are not real, find the set of values, meaning inequality, of k. So here we already know that the roots are not real, and you know the rule, that means the discriminant b squared minus 4ac has to be negative. Remember, inside the square root it would be negative. So this is given, so we can plug in the values. So b is coefficient is minus 2, b squared minus 4, a is 1, and c is k, so less than 0. We can write 4 minus 4k less than 0. Now all we have to do is solve this linear inequality. So we can write minus 4k less than minus 4. Therefore, if we divide by minus 4, the inequality would be reversed, as you know the rule of linear inequality. So this would cancel off and it would become 1. So k is greater than 1. So the set of values of k would be k is greater than 1. That's it. Let's do some more examples. So the first one, find all the values of a such that ax squared plus thrice x plus 5 equal to 0 has two real roots, meaning the roots are real and different. So we can do this. So b squared minus 4ac is greater than 0, meaning the roots are real and different. So we can write, so b is 3, so 3 squared minus 4, a is a over here, and c is 5 greater than 0. So this would be 9 minus 20a greater than 0. So if we solve this, it would be minus 20a. It's a linear inequality. If we send the 9 to the other side, it will be minus 9. Therefore, remember, if you divide by a negative number, the inequality reverses. It will be minus 9 by minus 20. So minus minus cancels. So the set of values of a are, a is less than 9 by 20. Now the next example is, find all the values of a, meaning set of values of a, such that this quadratic equation has one real root, meaning the roots are real and equal. So b squared minus 4ac would be equal to 0. That means b squared means 48 squared minus 4. A is the unknown value a, and c is 64 equals to 0. So we can solve it like, let's keep it 48 squared and we can send this to the other side. So it would be 4 into 64 is 256 a. Therefore a equals to 48 squared divided by 256. Let me calculate this. 48 squared divided by 256, and it is 9. So a equals to 9. Let's move on to the next one. Find all the values of a, meaning the set of values of a, such that this equation has imaginary roots. So imaginary roots means b square minus 4ac is going to be negative, so less than 0. So we can write b squared. So this needs to be rearranged. This is 3. Yes, it doesn't need to be rearranged. So b squared minus 4, a is a and c is minus 6 less than 0. This is going to be 9 minus 4 into 6 is plus 24, a less than 0. So we can write 24a less than minus 9. Therefore, this time it's not negative, so the inequality symbol will not be reversed. So minus 9 by 24. So this is, and the final one, this one is find the set of values of p for which the equation has unreal root, same as imaginary root. So what we have to do here, so b squared minus 4ac is less than 0 again. So b is the coefficient of x. If the quadratic equation is not arranged, you need to arrange it in the format of ax squared plus bx plus c equal to 0. This is very, very important because sometimes they can be on one side and the other side, so you have to rearrange it. So here, so b is, this is plus, I think, plus 2p. So this is 2p whole squared minus 4. A is 1 and c is 10 minus or plus. Let me use this as plus. So 10 plus 3p less than 0. So what you do, you multiply, this would be 4p squared minus 4 tens are 40 and this is 3p. So 4 3 the 12p minus 4 tens are 40 less than 0. Divide both sides with 4. This will be p squared minus 3p minus 10 less than 0. So maybe there is a, it's not clear this whether this is plus or minus. So whatever it is, so you can do middle term break. So p squared, so 5 to the 10. So we can write minus 5p plus 2p minus 10 less than 0. If we take p common, it would be p minus 5. If we take 2 common, it would be p minus 5 less than 0. So it would be p minus 5, p plus 2 less than 0. Now we have to use quadratic inequality. Remember, we use the critical values. So the critical values would be p equals to 5 and p equals to minus 2. So if it is less than, think about the parabola like this. So this would be minus 2 and this would be 5. So less than meaning this region, so it would be enclosed. So we can write the answer to be minus 2 to 5. Now for sets of values of x, you can write x colon and you can give the set notation. Let me do 2 more examples. Here, we don't have to find any unknown values of a or any constant or any set of values. Here we just have to know what the determinant is, and from that determinant all we have to say how many roots there are and what is the nature of the root. So let's start with the first one. So let's find the value of b squared. So b squared minus 4ac over here is 6x squared minus 4 into 1 into 4, because a is the coefficient of x squared and c is the term without any x. So this would be 36 minus 16. So obviously this is going to be a positive number. We can write, since b square minus 4ac is greater than 0, roots are real and different, meaning there are going to be two different roots, and the nature is going to be, they're going to be real roots. Now the next example, again we can write b square minus 4ac. We don't know what the value is, so let's find. So b is the coefficient of x. The coefficient of x is minus 5. So minus 5 squared minus 4a is the coefficient of x squared and c is minus 34. So this would be 25 plus 4 into 35 is also going to be a positive number. So we can write, since b squared minus 4ac is greater than 0, even here the roots are real and different. So if the discriminant was negative, we would write that the roots are unreal. If the discriminant was exactly 0, we would write that the roots are real and different. That means there would be only one root.